Very good evening to one and all. This is Prakash, National Secretary, welcoming you all on behalf of Indian Institute of Plant Engineers, IIPE. Today we have technical guest lecture on power system and I welcome you all on behalf of Indian Institute of Plant Engineers for this technical guest lecture this evening. The topic is power management and conservation in industries by engineer Er.R Neelamegan. He is a BE certified energy manager. He is having close to 35 years of industrial experience. He has worked on various industries. Currently, he is also consultant for Quality Quest Engineers and Er.R Renewable Energy. He stays at Salem, Tamil Nadu. We are eager to listen to the lecture of engineer Er.R Neelamegan. I welcome you, sir.
Thank you.
Over to engineer Neelamegan.
Thank you very much. It gives me immense pleasure to be once again with plant engineers, because during COVID and after COVID also I was mainly concentrating on institutions, engineering students and this thing. That type of lecture was different. But amongst plant engineers, something I look forward to. So I hope another 40 to 45 minutes will be interesting for the plant engineers. Okay, right away I will start my presentation. If everything is okay, audio and video. Okay, now, as in any industry, I think either you would have experienced this in the past or you are experiencing now. The maintenance department in any industry is looked down as an expense, liability, because we always approach the management with the expense in our hand. Either it is a project, or it is a maintenance problem, or a breakdown, with everything, we go to the management with the expectation of money. So once even when my vice president told, whatever you do, you are a minus to this industry because you are always asking for money. So that was the case. But I think in the recent past, it is not that, because we have merged into energy conservation, energy efficiency, so that we can also give some monetary benefit to our establishment. So that's where most of the engineers, they concentrate, because 70% they spend the time on maintaining machines and power system. At least 30% they can spend on energy conservation, so they can get a good name from the management. So in that angle, today I'm going to give some tips how to minimize losses, or how to at least gain. We have a gain this thing in our day-to-day activities in an industry, typical industry, with my own experience, what I have experienced, what I have done in the industry so far to get some monetary benefit to the industries we are working at. So in the cost saving without any investment is first attractive. Our management will be very happy if you say that cost this much is saved without any investment. So that if you do one or two projects in that and we achieve the desired result, they will have belief in us. So we can slowly start spending something for less investment to moderate investment, so that the major changes, without many major changes, we can do energy conservation things projects. Then we can go for major thing. We will our management will be with us, because they have now utter confidence on us. So one such improvement which I have done in the industry without any investment is demand side management. Now, before that, I just want to remind all of you, I think you are all aware of, in Tamil Nadu, the tariff has changed like this. The maximum demand cost is now 550, because it was 350. They have changed 200, they have increased. Then unit also 25 paisa they have increased. And above all that, they are saying every year they are going to increase it. Depending on the consumer price index, they are going to revise the tariff every year. Minimum 6% they are going to increase. So at this point of time, with this background, it is very important that we take some drastic measures so that the cost is kept, EB bill cost is kept on a manageable level. Because this year this month there's going to be a shock, because the energy bill is going to come, EB bill is going to come far more what we have been paying in the past. So one way thing is, I have shorted down into 5 major categories. The aspects of power management in a power sector is in EB, time of the day, maximum demand, power factor, harmonics, voltage and frequency. So these are the main constituents which contributes to our EB bill. First thing is time of the day, because they are not charging the tariff equally to all the throughout 24 hours. See, the peak hour they have changed to 6 a.m. to 10 a.m., 6 to 10 p.m. They are charging 8 rupees 45, 25% more than what they charge in general hours. General hours 6 rupees 75, and night hours they are giving 5% rebate. That is not changed. So 6 rupees 41. So with this different in tariff, by just altering the way of working, the method, the sections which are working in the general shift, you can just shift it to night shift. The section which is working in peak hours, slightly modifying the time. With this thing, EB bill can be brought down. You won't believe, in one case study which I have done in the tire industry, in development there were some 8 numbers, 7 to 8 numbers, 210 AC, which was working, which will be switched on by 8:30. The office will start at 9 o'clock, 9:30. Office start at 8:30 to 5 p.m. So it will be switched on by 8:15, 8:30. The major input for the AC will be during that time, 8:30 to 9:30, because it has to come from the room temperature to the desired temperature. Then it will work on thermostat. So the major chunk it will be switched on 8:30. So slightly the timing was changed for the development section alone from 9:30 to 6 p.m. so that the peak hour switching on the AC was avoided. So by simply changing the timing of things, we were able to save 8 numbers, 210 AC. You can just calculate how much the saving would have been. Same thing, there was a sand blasting section whereby they clean the mold by blasting sand. There was huge blower motors there. Those also, these molds will be like in the general shift only. These people will come in general shift, they clean the mold and keep it ready for second shift and third shift usage. What this was, we changed the timing into night shift. Only in the night shift they use short blasting. So by doing that, blower motors were running only during the night where the tariff was low. So these are the just simple 2 case study I have put it here. By just altering the timing of the activities, because in your 24 hours running activity, you can't say every section is working in 24 hours. Okay, agreed. Admin block, the computer centers, the management, everybody will be from 9 to 5. But we can't change the time. But certain activities in that area, being it a utility or being it a section like short blasting or this thing, that can be altered. So without any expense occurred, because already a supervisor there, workman will be there, so there will be available manpower. Only thing is we have to change the shift timing. So by that we can achieve. This is one thing. The next thing is time of the day. The next thing is maximum demand. This is demand side management. I all know, like by just flattening this curve, we can distribute our load so that our maximum demand comes less. Remember, we are paying 200 rupees more than what we used to pay last month. So this is a case study. This is a classic case study whereby in costing department, in accounts department costing, they prepare a costing for the product, what we make. The raw material cost will be there, labor cost will be there, then administration cost will be there, overhead will be there, then electrical cost will come. This electrical cost, they just divide the number of units consumed in that month by the total energy bill, not that unit cost. Total energy bill, what is the cost? They divided and say this is the unit cost for that department. In A, both the unit I was looking at. In unit 1, the cost was 7 rupees 28 paise. As you can see here, it was 7 rupees 28 paise. The unit was this and maximum demand was this. I have put the old rate only. I have changed that. It was there. Now, in another unit, which was by the side, it was working for tube. It was manufacturing tube. The consumer unit was this, maximum demand was this, and the unit price was 8 rupees 25 paise. So when they include the tube cost, the cost they arrive electrical, that's labor cost, raw material cost, and administration overhead. They include this electrical cost as 8 rupees 25 paise. So how many units are spent on curing or tube building? Everything they calculate and they put this is the cost for the tube. Plus this cost plus profit is the selling price. So why is different? Almost 1 rupee is different. So how to reduce this cost? This we have to see that. See in A, the fixed cost is 30% of the total cost, whereas in B it is 23%. That means compared with the units spent, the maximum demand is high, which means once again that junk major machines are working in a particular time. All we need is a 15 minutes. 15 minutes, if you are switching on all the machine and stop that thing, the maximum demand will rise. So how to distribute this? Where all we can distribute these kind of loads instead of working at the same time? Why can't we distribute that? So in that we experience this. This is a classic example because as a statutory requirement in another industry, we have to treat the water zero discharge. As per the requirement for the pollution control board, the chemicals we use in the factory and everything has to be evaporated. If it come with the water, it has to be evaporated and water segregated, and the condensed chemical will come. That is again used to the process. So this evaporator will be running. The capacity was set, it can run in one shift. In general shift, it was running, and it will just clear the water. It will take back the effluent treatment. It will treat the water, and it will again give it to the process. So that one shift operation was shifted to night shift. So the evaporator will be running in night shift. That 90 kVA, we were able to save 110 kVA. Like we were doing it for 2 months, 2.5 months regularly, and we saw a reduction of 110 kVA maximum demand. So for the safer side, we kept 20 kVA and we surrendered 90 kVA to EB. So by running evaporator instead of a general shift, we ran it in the night shift and we were able to achieve this much money. So this can be thought of. And additionally, because of this tariff structure also, the 5% rebate also we got by running in the night. So this increases, and by surrendering the MD, maybe that power station can use that released MD for further expansion or for any new other connection. So that's why the people encourage us by to use less maximum demand, because they charge 90% of the sanctioned demand charges. Even when you are using the fully sanctioned demand or you are using low, you have to pay minimum 90% of the sanctioned demand we have to pay. So we have to be careful that we use more than 90%, 90 to 100%, 90%, 89%. If we use only, we are benefited. Otherwise, we will be using 70% of the sanctioned demand and we'll be paying for 90%. So carefully by seeing our past record, I think data will be there. By collecting the record data for so many years, we can see what is the sanctioned demand, what is the demand we are reaching continuously. So why can't we surrender the excess demand so that straight away the fixed charge in the EV bill comes down. So this is another example of that. So having said that, time of the day and thing maximum demand, now the power factor. Usually we find the power factor compensation is done in the main panel, that is central compensation. Usually the chunk of the capacitors are connected in the power station itself. And there are so many problems. Manually means they have to switch on and switch off depending on the load, during a holiday, during this thing, everything we have to manually do it. Now APFC panel has come, we have put. Now that APFC panel has come, the best, in my experience, the thing is 60% that is up to 0.8, 0.89, it should be in the central compensation. Then another 20 to 30% which should be in true compensation, means it has to be in SSB. Sub-switch boards, you have to connect the capacitor. So when the switch SSB is switched on, the capacitor comes into play, and the load connected in that SSB is power factor is maintained. And individual, that is individual compensation means in the motor. The motor incoming, we have to connect the capacitor. To my knowledge, 10 HP and more. All the motors 10 HP more has to be connected with the capacitor, so that when the motor is switched on, this capacitor comes into the circuit. So by dividing like this, we can easily maintain it in 0.96 and 0.94. Now in certain states, they are charging EV charging kVA, not in kWh. They are charging in kVA. So it will be more useful if you use the capacitor and maintain it at 0.98, so that the kVA will come down. Now the charges there is like up to 90, no charges, but if it goes below 90 to 0.85, for every 0.01 reduction, I think 1% of the 1% penalty is given of the EB bill, and 0.5 to 0.5 it is 2%. Likewise, it's increasing. So reducing the penalty, not paying the penalty, but maintaining it above 0.95 is to our advantage. So this is a simple calculation. How much? See what we are power factor we are now, and what power factor we are able to raise. See, if it is 0.72 and 0.95, it's cross inverse of 0.72, 0.95. Using this formula, we can get the KVR which we need. This KVR having arrived, we have to diligently work whether we have to connect it to individually or in the group or in the main panel. So by distributing this, we can achieve 0.96, 0.97 without any problem. And maintenance of capacitor also is very good, like we have to taken care of. So only you just loading the current, just with the torque tester, we check the current on the three phase. As days goes by, as the years goes by, the capacitor will draw less current. That means it's getting weakened. It's not instead of going for a new capacitor, we can replace this capacitor. Now the tube capacitors are available. It's not like yesteryears where the old capacitor, there's a big thing changing it. But now tube capacitors have come, we can change it. So this is on the part. So I had a very bitter experience. Before putting automatic power control panel, we were doing it manually, whereby the shift person forgot to switch off the capacitor bank on a Saturday, and Monday was a Republic Day. So 2 days it was running in lead power factor, and we have to pay nearly $1 lakh on penalty. Because the next after the Republic Day, the next day is 27th, where the meter reading is being taken. So we had a very bad experience on that. So we have to maximum go for APFC panel in the main panel. Then automatically when the SSB is switched off or motor is switched off, the capacitor will not be in the circuit. So we can easily maintain above 0.9. That is base. Then while running, it can be maintained to 0.98, 0.97. This is another like the tips on power factor. Then comes most dreaded subject of every engineer, I think, the harmonics. Suddenly we found breakdown which is not expected at all. The culprit will be harmonics, which cannot be measured easily, which cannot be like pointed. So they have now come with penalty for this, that is 33 kV and the whole system. And shortly, I think for 11 and 22 kV also this will be. I think already they have done it, or they are on the verge of doing this. They are going to measure the harmonics in the incoming of just after the meter and before our transformer. They are going to check this, and if it is 5% for individual harmonic content and not exceeding 3% for individual. So we are going to get 15% penalty for this. So even though we are in 22 kV or 11 kV, most of the industries, we should be aware of this and we should prepare ourselves before itself. And here one point I want to mention is they will come and check, and if that this thing is level is harmonic level is more, they are going to penalize us. But what is the harmonic they are feeding into our system? That we have to find out, because some other factory by the thing also will be creating this noise in our system. So there are a set of calculation for substation. The power which is coming from the substation to our industry. In the substation, there are norms. There are 5 categories. They have divided into 5 categories, and the substation will fall in any of this category. And in each category, they mention this is the limit of the harmonics they can have. So that record also we have to ask from the EB persons. We have to ask what is the harmonic level in your substation, which category you are under, and what is the extent of harmonic in your thing. Then you can check in the permission and see how can we go about it. And to tell you frankly, this is the headache, because any new now all the thing has come in electronic way. Even LED lights comes with the driver. So that drive chip chops our sinusoidal wave, which is a smooth sinusoidal wave. Once it goes to LED bulb, it becomes something like that, because we are rectifying it, we are boosting it, we are bucking it. Whatever you do, we are doing it because we have instruments, we have this thing, what you call spare, what can do every injury to this sinusoidal wave. So we should be careful. Whatever we put, see, if you are putting LED like hundreds or 150 in an area, in the light control panel, we can have to put a thyristor control, or we have to put a suppressor, harmonic suppressor. While designing that bank also, bank itself, if you put a harmonic suppressor, that problem will not be that problem will be mitigated. It will not be extended. So by extending all these things, putting your like PFD drive, putting LED bulb. So I have listed the thing: electronic fan regulators, UPS, battery chargers, the variable frequency drive, electronic choking tube light, arc furnace. Well, these are all the main gadgets where we get produce harmonics, and be assured these will not be affected at all. The person, the instrument or the machinery connected down the line or upstream of this are going to be affected. So as maintenance engineer, we won't be having a clue why this accident is happening, why this breakdown is happening. The culprit will be somewhere sitting coolly, working very well without any problem, but producing harmonics. So see, harmonics, I just want to, like my analogy to my this thing, I just put this. This is a harmonic whereby we say a simple flowing sinusoidal wave, that is C, hitting a rock here. Once it hits a rock, that is, you can say in variable frequency drive, it just stops the waveform and with this created frequency is adjusted. So what happens? There is a backlash. Like just in this waves, a backlash is there. The backlash will be maximum near to the rock, and then diminishes as it goes far away. Likewise, third harmonic will be the highest, then fifth, then seventh, then ninth. It will go on diminishing. So to arrest this, just imagine you build a wall with the mesh and all, so that the reflected water is just filtered or slowed down and it is let out to this stream, so that this wave is not that much ripple is not that much magnified in the upstream. So that is harmonic filter. If you put a harmonic filter as and when you add gadgets, the harmonic problem can be mitigated. So this also very recently, like in 2014-15, we had a very big study on that, and we had a very big problem. See, this example, one this thing, classic thing has happened. I don't want to mention the name or place. See, this is what happened. They checked one one person came with heart pain. They checked it, and they declared he had a heart attack. When he went for a second opinion, in the nearby hospital or something, they can't afford to that hospital. They went to nearby hospital. They said, "You are perfectly all right. We haven't suffered." The culprit was this. The input was like this. Your heart is fine. The input was like that. You had a heart attack. So this, you have to be very careful on harmonics. See, in what are all the equipments this harmonics plays a role? In motors, it's losses, excessive overheating, reduction of capacity for use at full load, because certain motors will trip without even reaching a full load, it will trip. We will be breaking our head, what is the problem? Because the operator will say motor just trip. So we put a analyzer, power analyzer, count tester, whatnot. We just monitor it carefully whether it is going up the this thing maximum load it is going, whether it's tripping in that area. Nothing like that. It will be in 80%, 80%. It will not go excess over that. But the motor will trip. So this is the problem. Losses, excessive overheating, reduction of capacity, use at full load, torque, noise pollution, isolation transformer, there is loss in ohmic iron, loss overheating, mechanical, vibration, noise pollution, circuit breakers, unwanted tripping, exceeding voltage peak values. This harmonic combined with low voltage. Low voltage means I am talking about 390, 395, 400. In some places, we get constantly this voltage. This voltage for 390, 400 will not create any problem. But if the harmonics are present, the circuit breaker will trip. The circuit breaker service person will come. He will just show us, see 400, it will not trip. We have adjusted, nothing is going to happen. But once he goes, steps outside the factory in 400, that circuit breaker will trip. Somewhere inside this harmonic will be playing role. Cables, additional dielectric and ohmic losses will be there. Neutral conductor losses, operating problem, and power electronics problem related to waveforms, communication, synchronization, power capacitor overheating, premature aging, resonance. These are all the problems for harmonics. And voltage, this much problem we have in voltage: under voltage, over voltage, unbalanced voltage, flicker, transients, interruptions, and of course harmonics. This, I think, over voltage, there was a problem because we had a dedicated feeder from substation. A dedicated feeder was feeding one of the section of plant where we had this over voltage problem. During Sunday, we will be running only one section because which is still lagging in the production. So they say only this section can work on Sunday. Rest all will be switched off. On that Sunday, we invariably face this problem. Over voltage testing compensation will trip and there will be some problem. So what we have to do, we can't change the tap of the transformer. We can't change every Sunday we change the tap of the transformer and Monday we come to this thing. It's not possible. So we have to coordinate with the EB people and say like medium, it should be 430, it should not go more than 430 and it should be in 410 range. So this in dedicated feeders and factory which is very near to the substation, we get this problem. And over voltage, most of you would have experienced areas in the tail end areas, we experience this problem. This unbalanced voltage, this unbalanced voltage, we have a norm. Even in EB bill, the thing is unbalanced is 1.5% should be the that is in all the phase RY, YP, VA, we just measure the voltage. You take the average, the maximum voltage minus the average by average will give you the percentage. If it is more than 1.5, we can claim compensation from the service provider. That is there. In the EB bill also it is there, but we don't check and we don't claim any refund also from them. Penalty also from them. And this voltage imbalances causes extremely high current magnitude, high current imbalance. So terminal overheating. Unnecessarily, we can see always see a phase in the thermal box of a motor will be in black in color, heating, and it will be brittle. It will become brittle. Unnecessarily, there won't be any problem. There won't be anything. But unbalanced voltage is the culprit there. Unbalanced voltage, the problem is mostly, to my knowledge, is inside the factory itself, because the single phase equipment without any control, electricians and electrical supervisor, everybody, they connect single phase equipment in the DB, that is the distribution board, without any control. All grinders, bench grinders will be there. There will be even in single phase welding machines will be there. Cleaning, vacuum of everything in single phase, they connect it in the DB. So you see, in connected, there it will be easy because our phase will be very easy because it is very much just to remove that, top of it, you just connect it to the fuse and you just take that temporary connection. So in one phase, all the single phase equipment will be loaded. So when the motor is running in the DB is running, means we get this problem. So these kind of problems can be avoided. This is in the voltage side. So voltage flicker and transients can badly affect the electronic components. See, in recent to my this thing, after 10 months or 6 months before, my computer packed up because of this flicker. Then voltage interruption may lead to production loss of product. This because once the voltage or once the power goes off, if it comes after 1 hour or 2 hours or 8 hours, it doesn't matter because we have backup generator, we can switch on and we can do it. But this interruptions, whereby it goes and in the 2 months it will 2 minutes it will come again. So the electrician will be in the dilemma whether to switch on the generator or not. So you switch on the ACB, then again it trips. These kind of interruptions is more does damage more than the power failures. And last but not the least, this frequency. So frequency, we also the EB has set a limit plus or minus 2.5. Now I think it is 1.5. We have come to a stage where it is 50, 49, and 51. This is over 2.5 is not there now. I think it is minus 1.5. So we are maintaining that frequency, but occasionally we get into this problem in areas like mesh belt furnace, in furnace areas, in mesh belt furnace, in that locality, whereby suddenly that furnace is switched off or something trips in the furnace where the bulk load is there, a slight fluctuation variation is there. This can be sensed when a motor connected, a small motor, not a very big motor, a small motor, spindle motor, this thing connected with the variable frequency drive. If it is connected in that line, if this major load is suddenly switched off, there will be a minor disturbance in the frequency which will affect the quality of the product. This also, once again, it's a nagging problem because after the shift end, the QA will come that this thing product is rejected because this has happened. So we will be breaking our head what has happened. So on thorough investigation, we plot the thing throughout the hours, 7.5 hours working, in which hour this product was made, in which time period it was done. Then when we just correlate with the other section, we found out that this mesh belt furnace was the culprit. For some reason, for carbonizing or from clogging in the thing, the operator switched off. Within 5 minutes, he has cleaned and he has again switched on. So there was this minor disturbance in the problem. So this frequency problem also has to be taken into account as the maintenance person's purview. So this cannot, this also cannot be ruled out. So what I am trying to tell you is power, like control, power system control, mainly depends on all these 6. The electricity bill can be reduced in time of the day, taking in maximum demand, quality of power and power factor, harmonics, then voltage and frequency. All these 6 should be maintained, recorded, data collected, and watched carefully to minimize breakdown. So this is what I was trying to say. So frequency variation effect. High prescribed value leads to increased speed and friction and vintage loss in motor. High frequency leads to increase in transformer losses. Core loss will be more. High frequency loss in conductors due to skin effect. Low frequency leads to low motor speed and output losses. The motor may be able to maintain the same torque, leading to premature failure of the motor. So flickering of lamps. Variation has bad effects on computer control that we have experienced. Data loss, system crash, everything will happen for in this frequency variation thing. And having said that, I think I have another 10 minutes. I'll just touch upon not very briefly about this motor cost saving opportunities in motors. See, everywhere we find now the thing is the fashion. maybe we can say the fashion is connecting VFD to the motors. Nothing wrong. Yes, VFD, we have got a technology whereby we are change the speed of the AC motor, because initially it was in the 80s and the early 90s, it was only DC motor where we can change the speed. We are to have DC motor. Now AC motor, with this advent of frequency drive, we use this extensively for changing the speed of the motor, thereby getting monetary benefit. But whether it can be used everywhere, no, I don't think you can use it, because whereby you need only a two speed, only reduction of the speed once in a time of the life of the motor. So waste using a VFD drive. We can have some other. We have so many other methods where we can reduce the speed of the motor and forget about it. It can run in that speed. Where we require frequent speed variation, there we can put the VFD motor. So that is the main cause, because I'm insisting on this, because maintenance, I know maintenance engineers who lost their creditability by simply fitting the VFD motor and not getting the desired result. It was not there because it was a constant torque. They just fitted the VFD saying that there will be that much save. Because it was a constant torque motor application, the thing was not there. The expected saving was not there. So on above that, there are so many things. Downsizing underloaded motors by replacing it. Recent IE5 has come. So IE3 or IE4 motor can be replaced. Can be put in the place of the old motors. Downsizing of the underloaded motor electrically, that I have a case study, I will let you know. And loading the motor to its opting capacity by increasing the load on the motor, that also can be done. Eliminating motors by connecting all this. If there is air available, if there is water pressure available, you can use that instead of a motor. Then VFD drives, of course, for blowers and AHUs is very useful. Then starter for large motors. Then here I give a classic example where in a factory in a cooling tower, there's a 10 HP cooling tower, we had aluminum blade cooling the impeller, which was changed to a much lighter casting. It was not a casting, it was FRP. FRP blade we changed that. Instead of aluminum casting, we changed to FRP. The load drastically decreased and it was loaded below 50%. So what we did is we just changed the starter into star delta star starter. So this was the saving. 15 HP, load current 11 amp, full load current 23, it was taking 7.5, units saved is 53, 1 lakh by just electrically downsizing the motor, we were able to gain this. And we have another example in compressor house, one motor which was loading and unloading motor, the third motor, because we have 4 motors of 60 HP. That one compressor motor which was in oscillating mode, it was loading and unloading frequently, it was just for that small section. We found it was underloaded when it was running. So we changed the pulley size in the right side and made it to optimum load to load. The resultant is the output increased. We were able to take a 60 HP motor out of the line. So 160 HP motor taken out of service, you can imagine what will be the. I had the calculation, but I couldn't find it. In a few days, I couldn't just find the calculation. So the equation this 120 FP, how the torque is not going to affect the speed is decreased, the torque is going to increase. So for constant torque or constant power requirement, VFD is not it is recommended. Only when the thing also variable torque like blower, AHUs, these areas we can use VFD to good effect. So like the constant torque like conveyors, agitators, crushers, positive displacement pumps and compressors. VFD compressors means I am talking about screw compressors where the torque is constant and is running through. VFD is not going to be of much use. So this. So this is a simple Sitar boiler in '96. We changed the ID fan and FD fan instead of damper control the incoming air. We changed into we fitted drive, and this was the cost saving we had. And to all like plant engineers, my request is energy conservation, efficiency. It, instead of calculating, instead of projecting and calculating, it's better to connect an analyzer and see for 1 week without the DFT drive or without the like process what you are going to do, without that. Then after the improvement we have done, we just connect the power analyzer and check all the parameters and the units also. Like this, we can easily point out what is the units saved. So in one of the molding machine also, in the molding machines, we have 14 molding machines. In that also, we attached this energy power analyzer and calculated the units for 1 week. And we fitted this VFD variable speed drive for the hydraulic motor, whereby the cycle time, what do you say, that the eject time, holding time, then remove time. So all this time, the pressure will not be, the motor load will not be the same. It will differ. According to the load, they will have differential pump. So instead of that pump, if the motor load is varied, motor speed is varied, we get the desired result. So that also we practically proved, and we fitted the VFD drive to change the speed of the motor in a cycle throughout this 14 molding machines. So, and of course this compressor with the VFD, you get that on and off time is thing. This I have taken from our refresher board. So instead of switching on and off, it will be constantly running with the VFD, the slow speed and high speed. That way, the pressure is maintained. I think I am on time. I will take some questions. It's back to you. Yeah.
Yeah, thank you so much, sir. I think we have a lot of questions in the chat box.
Yeah.
I'll just go through the questions and read it one by one. You can answer it. There is some background, some noise from your mic or from some participant. I don't know.
Yeah. There is a noise.
From mine?
Yes, sir.
I don't.
I request members to switch on their camera.
आदत लगना या